Okay, let's get started with question 1 of the case, JMP034. Question 1, as I've copied here on this separate screen, says to create separate logistic regression models for each of the 4 screen types, describing the relationship between success rate and drop height. So we'll do that first, and then the second part of question 1 says show graphs that display the models along with the observed success rates for all 4 screen types. So I had to give that one a little bit of thought, but I believe that is all included in our output that we're going to get. So let's go ahead and run the first analysis of the question 1, and the case is nice enough to give us instructions for how to set this up here. So we're just going to follow those instructions and see what we get, and I suspect we're going to run into one slight problem that we'll see in just a bit, and I will show you how to fix that. So for this run, we're going to do analyze fit y by x. We take outcome to y, height to x. This is all straight from the case so far. Height to x, count goes to frequency, and screen goes to by. I don't know what they say in the case. You have an option to do this with the global filter. I have no idea why you'd want to use the global filter, because using the local filter, or I'm sorry, the by value here does that automatically. So we're going to get all 4 analyses at once by running this. So with that set up, that's all the setup we need to do. Press OK, and let's take a look at that output. Okay, so looks pretty good, but what's wrong here? It's like a up and down mirror image. So what's happened here is the model that we ran actually was modeling the probability of failure. Okay, and notice on their chart they have fail on the top right and success on the bottom. Our chart is reversed to that. We have success on the top and fail on the right. So what this is saying is it's the model's actually giving you the probability of failure instead of the probability of success. And so let's fix that. Now I had to do a little work to figure out how to fix that, and the way we're going to do that is kind of a hack, but let's go to the outputs little red triangle here, and I'll show you a cool general trick that can be widely useful. So for any jump output that you have, go to the top little red triangle, and if you go down here and you want to pick redo, and make sure that you always pick relaunch analysis, not redo. Relaunch for this hack, and by doing that you're going to open up the original input box that you used with all the settings that you put in it. Now usually when you do that you're going to get the exact same input box, but I found by experimenting a little bit with this that by doing that here we're going to get this box that has it's more specific to a logistic regression, and it gives us the ability to set the target level that we want. So what I suspect is that fail is probably the first data value that it encountered in that variable, so it made that the target level by default. So we're going to go in there, we're going to change fail, and you're just literally going to type out success on the keyboard. Double check, make sure that your typing of success matches exactly how it's entered into the data set. Enter. So we've now set our target level for that, and we can go up here and close the original output. So everything's the same setup with the target level changed to success. We're going to tell it OK, and let's see what we got here. And there we go. That's exactly what we're looking for. So it matches up with their example output. Now, a couple quick other tips I want to show you on here. So what I'm going to do is I'm going to change the layout of this output box, and I'm going to do that by going to the top little red triangle down here, the first item layout, and we're going to change that to a horizontal list. This is cool. And now if I just move it over a little bit, we now have all of our 4 outputs together here and able to easily be read and worked with. So one other or two other adjustments that we need to make per the instructions in the case assignment is to change our display of these plots to match how they want us to put it. So to do that, we're going to go to little red triangle at the very top and down here to plot options. Now we got to do this twice. The first time we're going to turn off show points, and the second time we're going to do plot options and turn on show rate curve. So boom, there we go. There is our completed work for question 1. So having that now completed and being satisfied with it, let's go down here to top little red triangle, down to save script, to data table. And always you want to do to data table here. And I'm just going to call this one Q1. So just enough to differentiate this script from other scripts in this particular modeling process. So Q1, okay. And you'll notice that in our JMP data set, we now have the script up there. So I close that output down. Now if I just want to get the same output up, I can just come over here. Sometimes left clicking on the little green triangle will open it. Otherwise right click on it and tell it run script, and it is going to be there just like we had set it up. So cool. Now just one last thing here. Let's take a look at that question. Let me find that here. Okay, so the first question, the second part of that says show graphs that display the models along with the observed success rates for all 4 screen types. So how I interpret that is that the blue parts of the graphs are the model that displays the model, and then we also have the numeric substance of the model in the following output, but we're not interested in that at this point. So the blue line shows the model graph, and the green line with each of its with its corners on here, each of those is a data point from our data set that shows the observed success rates. And then that's done for each of the 4 screen types. So the observed success rate, you could go here to the output, and it looks like that's at a height of 2, and that was about, I would estimate 10% or somewhere right around there. But that's meeting that requirement. We're showing both the model and the observed success rates on this graph. Okay, on to question 2 here. So back to our original JMP data set. We just now have the question 1 script saved over here. Number 2, for each model, provide a point estimate and a 95% confidence interval estimate of the success rate at a 1.0 meter drop height. So let's go ahead and run that, and then once we get that set up, we're going to grab that data out of there and put it into a separate table in order to create the visualization here and allow us to do the rest of the question in comparison. So let's get going on that one. Let's look at the tips in the case. So this walks us again through the process of setting up this run here. And before we run it, I just wanted to point out one possible thing that might go wrong in yours. When I first ran this, it was just like in question 1, it was giving me the reverse of this. It was giving me the probability of outcome of failure. And I wasn't able to figure out how to change it within the model. So what I wound up with is, notice in the outcome variable in the JMP data set here that it tells us at the top that there are 2 values, 2 unique values, and this also tells us the ordering of those. So what I'm going to do is right click on the column name. I'm going to go to column properties, and I'm going to go down here to value order. Click on that, and notice that these have already been pre-coded with a custom order. And in this case, our custom order is checked here. and we've selected, or someone has selected success and fail. So without that custom order, it's just going to use the sorted order, which is alphabetic. So fail would always come first in the sorted order. But custom order, notice now that it defaults to fail, then success. So I'm just going to come over here to reverse, blip on that, and we got success on the top here. So that's how we want it to be. And that, I believe, is the way that you need it to be set up in order for the model to know that you want to do the probability of success for the model. So anyway, I'm going to cancel that because we didn't change anything. But let's go ahead and run the model then. So let's run the model, and if it turns out the right shape, then we don't have to do that. So analyze fit model. And then we're going to set this up, and note that we used fit model here and not fit y by x. So we're going to take our outcome, run that over to y, take our height, and this box down here, it's like the X version of the fit model. It's just a fancier capability model, so they call it the construct model effects, but it just means X as far as we're concerned. Count goes to frequency, and screen goes to by. So we'll do all 4 of our screen types in one run here. All right, a little more we got to set over here. So personality, upper right, per the instructions in the case. We're going to change that to generalized linear model. Distribution is going to be binomial, and the link function is the logit, and that came up there, so that's the one we want. So we're good to go on that one. We're all set up there, and let's go ahead and run, and our output looks like that. And what I'm going to do first thing here is do little right triangle, layout, horizontal list, so I can just see them all there. And okay, so now last thing we need to do on this to get ready to find our numbers for this question is to click on the little red triangle, go to and make sure you're doing the very top little red triangle. You could do this individually for each of the 4 screen types, but you'd have to do it 4 times. So by doing the top little red triangle, you go to Profilers, Profiler, and there we're telling it, hey, turn on my profiler for each of the screen types in here. Okay. And just glancing back at the original question to verify, make sure we're doing the right thing here. They want us to provide a point estimate and 95% confidence interval of the success rate at a 1.0 meter drop height. So that's the only drop height that we're concerned with here. And let's go ahead and use our profiler to come up with those values. So let's see, it'd be nice to verify that we are using 95%. That's default. Yeah, here. So confidence intervals, the thingy comes up and says show or hides the 95% confidence intervals. So if we wanted to, we could go above that and change it, but so we're good to go. We're on that 95% confidence interval that we're looking for, and we don't have to mess with that. So now the profiler is really cool. So for this, we could give it any input value, and it's going to give us the corresponding predicted point estimate and confidence interval. So the 1.4648, I'm not sure exactly how that's derived, but that's like a overall average or of something, but that's not meaningful to us. So, but for example, what we are interested in is changing that height to a 1, and we now have our numbers of interest over here. So let's go ahead and run that on all 4 of these models. I couldn't figure out how to do this automated, so usually it's just easier to go just left click on the red number down there, tell it 1 or whatever your target value is, and just do that for all 4 of these. So cool. So now we have all the data needed for this question. So that being the case, what I'm going to do is come up to my output window, very top little red triangle, save script to data table, and we'll call this one Q2. And cool, awesome. So let's pop back here to the question now. And the question says, create a table and a visualization that displays the point estimate lower and upper bounds of the confidence interval. Okay, so let's do that. All right, so the approach I'm going to use to do that is I'm going to make an entirely new JMP data file and use that one just for the question 2 data and that visualization. And I prefer that method because it nicely separates all the different sections of the work, and it's a lot easier to tell them apart and figure out what you're working with. So we go to new data table, and here we have our new data table as requested. So first thing I do is go up here to File, Save As, and so I'm in the same folder that I'm originally have my JMP data, the first data set in. So I'm going to call this one Q2 and Q2 table, just to give me enough information for what I need to know about it. Okay, cool. So I'm now going to just move this over here somewhere. I'm going to click back on that output that we just got, and I'm going to raise my new table up on there. So now we're going to configure this table to have the right settings for this data. So the way I'm going to set this up is I'm going to type lower bound first, and then I'm going to go here to the next one, and I don't want to quite do that yet, but okay, so we'll set it while we're going here. So this next one is going to be called point estimate, and we got to make sure that these two settings are right. So data type is numeric, and notice that can be, and the two ones that we would typically use would be numeric or character. So either the values are numeric and you can do math to them, or they're text, which doesn't have any math component to it. So this is definitely numeric. So it's numeric, and modeling type is continuous. We could also change that to nominal ordinal, which wouldn't make sense with a continuous variable, a numeric variable, but a discrete numeric variable could have data type numeric, and modeling type would then be ordinal or nominal. But this is continuous, so we're good on that. Everything else looks good here. Tons of stuff down here for tell it how you want to initialize it, or how many rows to make. And I'm not sure if we're going to do any formulas in this project, but if not, click on formula from that drop down, and that's your formula editor. But here we're good to go on that middle one. So while we're making our settings here, let's double check lower bound, numeric, continuous. Good to go on that one. We'll say click, 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 click. And this one is going to be upper bound. That also is numeric and continuous, so we're good to go on that one. And what I'm gonna, oh, you know what I forgot to do is make a column for the name of the screen. So just to be orderly, we'll make that over here, and then we'll move it over there to the first column. So screen type, or screen name is, and now that one is a character data type, because it's alphabet and text characters versus numbers. And modeling type, we're just going to call nominal. As far as JMP's concerned, nominal and ordinal are treated exactly the same way. So don't stress out about which of those two it's going to be. In statistics, nominal means that the values do not have a defined order amongst them. I remember that because no, NO, no order. And then and then ordinal, ORD, order, those do have an order to it. Like school grades is an good example of ordinal data. A is higher than B is higher than C, and that's understood universally. So that's what that's all about. So screen is going to be a text column here, and let's now see if we can move it. It's always a hassle moving stuff in here. So reorder columns, move select the columns, move to first. Okay, there we go. So that's what we like it to look like. So I'm just gonna go ahead and add these name values in here, A, B, C, and I'm just gonna call it the competitor X. So we'll know what that is. Now, I don't know of a handy way to have the jump output automatically put these numbers in, so we're just going to do it the hack method here, and we're going to just manually type them in from the output. So I'm looking over here at the screen A output, and the lower bound for that is the 0.76 number there, so we'll tell it 0.761549. Point estimate is still with screen A here, so that is 0.831388. The upper bound estimate is 0.883892. And we'll run through the rest of those. All right, awesome job on that. So we've now got our separate jump data table file with just the output information that we want from this output. So having that information, we verify that we have saved this script, which we have. So we're now able to X this out and work with our new data table here. So this is the table that displays the point estimate, lower and upper bounds of confidence intervals. So now let's make it into a visualization. All right, so on to the visualization portion of question 2. We have our data all set ready to work with here, and we're now going to use what is just about the coolest hack ever to do the kind of visualization that we need. So thank you to the internet link where I found this on that forum. Super helpful. I'll try and put that in the comments for this if you want to check it out. So here we have our data table ready to work with and graph. So let's go to graph builder, and it's gonna get us into a thing like this. So this is our initial page for doing the graph builder. And what we're going to do here is we're going to take screen from the variables list up at the top here. Screen is going to go down here into X. So by that we're telling it that's the independent variable here, and we're telling it we want you to give results for each of the levels of that. So that's what it's got down here. Now what we're going to do next is we're going to circle all 3 of the blue ones, and the blue triangle means continuous, the red bars are nominal, the green bars are ordinal data type. So we're going to grab all 3 of those blue ones and throw them over here into Y, and at this point you can kind of see it's taking shape, but it's not where we want it yet, so I don't know how in the heck you figure this out on your own, but the way that we make this into the kind of graph we want is we first want to make sure that we have this dot icon at the top clicked, and only that one. So that's what we had initially, so we're at that point again. Now, trick here is I'm going to press and hold Shift on the keypad. While holding Shift, I'm going to click on the vertical bars icon. Okay. Now, we're going to go inside the graph anywhere. We're going to right click inside the graph. We're going to tell it bar bar style interval. Okay, and we're just about there. So now we're going to go on the left side of the graph builder down here to points. And under points, we go to variables, and we're going to deselect lower bound and upper bound from the points. And go down here to bar, click on the bar variables, and from that one, we're going to deselect the point estimate. Cool, so that's what we're looking for. So, and I'm just going to work with this a little bit, make it more readable, and I'll show you my couple tricks for that. So, one thing we can do is we can go to the points, and remember that's only going to talk about the point estimate here because we deselected the other two. But click on labels. We're going to tell it label by value, and notice that it defaults to 2 decimal places of precision. So we want to get a little bit more than that. So I'm going to go to auto thing, and I'm going to come down here to fixed decimal. And the width, that's just telling it the maximum width that can take up. But we want to set our decimals to 4. So notice it defaulted to 0. By doing that, it has 0 decimals, and all of our point estimates rounded to exactly 1 with no decimals. But let's throw 4 decimals on there. So 4 goes into the decimal, enter, and now we have a nice 4 decimal description of the mean value there. So I'm going to click in there, get rid of that. Unfortunately, I didn't figure out how to turn the point values on and show those. I'm sure that that's in there, but I don't know how to do that. But so the last thing that we're going to do here is make the final graph a better shape that's going to better present the data. So to do that, I'm going to drag it down as low as I can, because what we're doing is we're stretching out the number axis here. So ideally, this probably, if you rotated this thing, rotated it counterclockwise 90 degrees and then mirror imaged it left to right, then it would be the ideal setup. But now we have our number axis on the left, so it goes from 75% at the bottom to 100%, 1.00 at the top, and then we have each of our ABCD confidence intervals displayed in the middle of it, or the relative to that number axis. So actually, what I'm trying to do here is I want this to be as compact side to side as possible, so it's easier to figure out where on the number line each value would be. But you want to, of course, make sure that it's readable and that the numbers are readable. So that looks pretty awesome to me. So what I'm going to do now is I'm going to tell it, okay, that looks cool. I'm done tweaking it. And so I'm going to hit done up here at the top left. And it's going to give me that nice final interval that we want. So that looks real nice. I'm going to go now to my little red triangle of that output save script to data table. And I'm just going to call this one Q2 graph. And that now has been saved to our second data table with this data in it. And we're now ready to use this as we see fit. And let's answer the rest of the question 2 here. So compare the performance of screen types at this drop height. So also in this, you'd want to tweak your graph a little bit more and change the chart title and stuff over here. And this one could change to probability of success. I forgot to do that when we set this up, but you can, and always when you have it in the done configuration, if you go to little red triangle, the first item there is show control panel, and that takes you right back to there. So So we can now click on that and tweak that out as desired. But let's take a look at what this is telling us. So each of these 4-line things is a confidence interval, and they are wrapped around a point estimate. So the point estimate is simply the exact proportion of success out of each screen type. So like screen A had, at the 1 meter height, it had 83.14% not fail. And that's what that means. So by the fact that all of 4 of these confidence intervals and point estimates are placed on the same axis, that allows us to readily compare them and figure out which is higher and which is lower and so forth. So compare the performance of the screen types at this drop height. So, and what the confidence interval means is that what we're doing here is called statistical inference. So we've taken information from a relatively small sample of phones that we dropped in this case, and we're extending that to represent the entire population of every phone that would be manufactured, with each of these 4 screen types. So that's why we have an interval estimate here. So we don't like to say that, I estimate screen type A has a 83.14% probability of success at 1 meter. What we as statisticians much prefer to say is that with 95% confidence, I expect that the population proportion of success for screen A is somewhere between 76.2% and 88.4%. That's what we're looking at. We're looking at here. And that pin's on there. That might be a possibility, but anyway, that's what it's telling us. But the numbers are they tie into the number line here, so we could just as easily look at there. But in general, compare the performances. So A is a dog. It's got way down here at the bottom of the percentages of success. So A just didn't step it up for the test and didn't do well at all. It only had an 83% point estimate, whereas our B and C models, and look at that, C was the one that was like a lot more expensive, but wow, B did better than C. So B is the best performing model of these 4. It's our best model, and how does the competitors' performance compare to our screens? So did better than our A screen, but that's not saying much. It overlaps our screens, and that's another way you can use confidence intervals to test for equality or not. Is if any 2 of these confidence intervals overlap, then it would be reasonable to assume that the same value could be the population mean of both of those. So overlapping intervals are considered to not be significantly different from each other, contrasted to like our A interval and our B interval. So there's a huge gap in between those 2. There's no overlap there. So the highest that we would expect to see A would be the 88.4%, and the lowest we would expect to see B would be 92.9%. So there's no one value that would be reasonable in both of those. So therefore, they're statistically found to differ significantly. So competitor-wise, it did better than our A, but worse than our B and C. And also, you'll notice that the longest one is the competitor's one. So that implies that one had the most variability of damage compared to the other samples. And that relates to the last part of question 2. Compare the precision in the estimates for each screen type. Which ones have the most precision? Precision is a statistical term that describes how precise our estimate is, for lack of a better term. So, and what that means is that the narrower that a given confidence interval is, the more precise it is, because it covers less of of an interval from lower to upper boundary, less of a number line distance. So in this example, we can graphically see it looks like B is a little bit shorter, little bit not as long as C. So I would say that B has the most precision, C has the second most precision, and I'm not exactly sure by eyeballing those, but both of those are, and we could, if we wanted to do, so that's, let's see, 78, so 18.4, 22.2 is that interval's width, and this one is, that's an easy one, 14 point, wait a minute, 80 to 94 is 14.9%, and this one is 76 to 88. Oh man, I did my math bad on that. That's, so what's that going to be? That's going to be 12.2. So the A interval is 12.2. The B interval was 14 point, or the competitor was 14.9. So therefore, between those two, they both are relatively imprecise because they're so wide, but the A interval is more precise than the competitor's interval. So which ones have the most precision? We just described that. B and C are pretty comparable in precision. They're almost the same width. And then you could also describe A and competitor as being, roughly comparable. But ultimately, the worst one is in precision was the competitors. Okay, looking at question 4 here. This one is not too bad technically. We're actually going to use our same logistic regression model output as we generated in question 2, because what we're doing here is like the inverse form of question 2's profiler. So in question 2, we gave it a specific drop height and it gave us the interval and point estimate for the probability of success at that drop height. Now we're just doing the inverse of that. We're going to give it a specific success rate, and we're going to ask it to give us the point estimate and confidence interval for the corresponding drop heights. So let's generate those first. So Q2 script is our big model that we made in question 2. So we're going to go to that one, and if we wanted to, we could actually minus down some of this so we wouldn't have so much stuff in here. So what I'm going to do is I'm going to minus down the studentized deviations graphs here because we're not using those. And rather than doing them one by one, what I'm going to do is press and hold Control. While I'm holding Control, press on any of the individual little gray triangles, and Control is going to make them all do that same thing. So cool, we got rid of those. Rest of this stuff's pretty relevant that we want to have. So now let's do our inverse prediction. So we're going to go up here to top little red triangle. And again, doing it through the top little red triangle is going to do it for all 4 of the screen types. Whereas if we did it through each individual little red triangle, then we'd have to do it 4 times. So come on down here and up there. We're going to pick top little red triangle, inverse prediction. And now don't get confused here like I did when I was preparing this. So we're doing a 95% confidence interval for a probability of success of 97%. So confidence interval implies two-sided, so that looks good. 95% is our confidence level, and we got to come over here and tell it specific values that we want to make predictions for. So we're going to tell it give me a confidence interval for the point estimate of 0.97 probability of success. And if we wanted to do other ones at the same time, we could do that by just entering those here, but this is the only one we're interested in. So now, notice it automatically added those to the bottom here, and we now have all of our screen types with the completed what they're asking for here. So, for example, in this first one for screen A, so getting to the interpretation of what we're given here, it's not, I'm not exactly sure how to zoom this in. I'm not going to try and figure that out, but in this table we have the corresponding values for that, and we're going to use those to make another visualization just like we did for the first question. So what this is telling us is that for the probability of success, 97%, that would fall on the vertical axis here, that the predicted point estimate of the drop height that would result in that 97% success would be 0.45 meters. So that is just doing a simple, X, or here we're starting with Y, so go straight over from Y, go straight down, and that's going to return a X of 0.45. So that would be our point estimate. That is the model's predicted point estimate. So we don't like to give just point estimates. We like to wrap something around it on either side a little bit. So we're going to go to the 95% confidence interval, which is telling us that with 95% confidence, the probability of success of 97% for screen type A would be expected to occur somewhere between a drop height of 0.159 meters and 0.642 meters. So that's what's telling us there. And same interpretation over here. So at this point, let's okay, so this is let's go ahead and build that visualization as requested in the question. Notice for this one, they're telling us, what question are we on? Okay, I think it's this one. Yeah, that's right. So here they're, in addition to what they told us to do in question 1, or was it 2, whichever, but the one that we made the visualization for, they're also asking you to give the width of the confidence interval in the table, and we'll see if we can incorporate that into the graph as well. So same setup as before, but we're going to add width to it. So let's build that. Okay, let's walk through that process real quick. And so we're going to go right back to our original data table jump file. From there, I'm going to tell it file, new data table, and we're going to call this one, well, let's get it on the screen first here. We're going to call this one file, save as Q4, question 4, and I think I called the other one table, so I'll try and use that convention. So Q4 table here. Actually, you know what? It'd probably be a little easier to just copy the other table and do it that way. But we'll just run through this real quick here. So we're gonna call this one screen. Screen is the only one of these that's gonna be a character variable. Notice when you pick character, it automatically goes to modeling type nominal. So we'll just be good with that. Okay. Next column is going to be our lower bound, and I'm giving a little thought here to ordering these to make sure and have them in the same order that we want them to appear on the chart. So lower bound, numeric continuous, that looks good. Next one is going to be point estimate, numeric continuous. Okay. This one's going to be our upper bound, and numeric continuous. Okay, oops, where'd it go? Let's see if I can find it. Dang, did I erase that? Okay, oh, there it is. Okay. Cool, awesome. So let's just finally add our last one in here, which is going to be the, how did they say it? The width of the CI. So we'll just, we only have one CI here, so we'll just call that one width. That's going to be a numeric continuous. That's okay. So we're now set up with our little table to enter our values. I'm just going to start this one off with A, B, C, D, and then we'll go back here to the output that we just generated. We'll show that along with our new table, and now our values we're just going to copy right from the outputs on here. So these are all 97% outcomes of success, so we don't have to write that down or anything. But for the level screen of A, we came up with a lower bound, and make sure you're grabbing the right number out of the output because they're not in the same order as we have them. That's going to help us graph this. Point estimate is going to be .4502.977, upper bound 0.64164994, and for the width, what we're going to do is we're going to just make a little formula for that that's going to figure that out. So let's do that. So I right-clicked on the column header. I'm going to tell it formula. That's going to raise the formula editor box for that variable, that column. And what I'm going to do is I'm just going to tell it to give me the difference between the upper bound minus the lower bound, or really just that. So we're going to say upper bound, bring that over here, minus, on the keypad, minus lower bound. That's all we got to do there. Okay. And we now have our width of that screen A, we know to be 0.4825 meters. So, and it'll automatically calculate the rest of those once we plug in these data. So let's fill in these data here. And there is our finished table portion of the response to question 4. All right, so let's get to building. Going back to our completed data table for question 4, we're going to go to Graph Builder, and same process that we did in the earlier question, making this visualization graph, with one exception that we now have a width variable in here, and I figured out a way that we can incorporate that into our graph as requested. So screen is going to go down here to X. I'm going to now circle my 3 confidence interval values, the lower bound, upper bound, point estimate. I'm not going to circle width, and I'm going to grab those 3 and I'm going to put them into the Y input thing here, with my top icon being set to only the dot icon. I'm going to press and hold Shift and click on the vertical bar icon. That's going to give me this. I'm then going to go anywhere inside the graph, or right click, tell it bar style, and interval. Now we've got to that point so far, so let's tweak that out, and we're going to go over here on the left side of the screen under points, and points, go down here to variables, click on that triangle to open those, and for points we're going to deselect the lower bound and the upper bound. And down here in bar, we're going to click on that, variables, and in that one, we're going to deselect the point estimate. So there we go. There's our graph configuration that we want. Now, what we're going to do is turn a couple things on here. So first of all, let's turn on the point estimate label, and here it defaulted to 1 decimal point, 1 decimal digit. So go to auto under label format. I don't know why it does that auto twice, but we're going to click on fixed decimal and make sure the width is 10 if it's not, or more. Just make sure it's not less than 10. So now it defaults to a 0 decimal, but we want it to give 4 decimals, so we're going to hit 4 there. Now we got the perfect the value label for our each point estimate on there. So we're going to cruise down here to bar, do kind of the same thing, but now we're going to tell it labels by value, and labels by value. We're going to do our double auto thing there, go to fixed decimal, and for some reason this starts us off at 4, so we'll tell it a width of 10 and a decimals of 4. And boom, there we go. That is our table. So the last thing I'm going to do here is just resize this just like we did in the first one to make it a little bit easier to read. And and that looks to be about good there. So that everything looks good. Double checking over that. So I'm going to tell it up in the upper left, done. And I'm then going to go to the top little red triangle, go to save script, and to data table. So let's call this one Q4 graph. Not sure how I named the other one, but that'll do. So we've saved that now. So our new Q4 table has a script in it, Q4 graph, which at any time we can run that script and re-invoke this exact same setup and this exact same output. While we have this up, let's go ahead and look at number 4 questions and address those. Okay, so we got our table with all the stuff they wanted there. Which of the models have the smallest and largest amount of error in these estimates? And I would tend to equate amount of error with being the width of the overall interval. So more interval, less precision, more error. So looking at this graph of confidence intervals, remember, just like the last graph we did in here, the y-axis in this case represents the meters of the drop, because that's what we're representing with our point estimate and confidence intervals, is the reasonable lower and upper values that we would expect for each of those screen types to produce a 97% success rate. So, and corresponding to our earlier findings that B is the best out of all of them, it's going to have the highest point estimate of 97% survival. Here it's 0.9436 meters, which and looking down here at the egg has the worst point estimate, which is 0.45 meters. But check out the competitors one. Look how wide that error is in there. That one's got by far the worst error because it's got a width of 0.7538 meters. And that's like the level A width, and half again. So most error with the competitors, and the least error would actually be screen C, which statistically there's no difference between 0.4209 and 0.4188. Those are statistically equal, but numerically the C gets the slight advantage there. So depending if you're talking numerically or statistically, that would answer that. Maybe give it both ways. Statistically they're equal, but numerically C's got the slightly smaller one. And again, you can do the overlay test here. So according to this, the competitors, and let's look at the numbers on this, if it'll tell us those. Let me make this active, do that. And so the upper bound value here is 0.864, which lines up with their 0.864. But that says that the most reasonable height that the competitor's phone reasonably could tolerate and have 97% success is that 0.86, whatever it was, 0.864. And notice with our B and C screens that, and we'll look at the best one here, the B screen, the point estimate, which would be the single most likely value that we would expect, didn't quite make it to 1 meter. We're getting a 97% success at 0.9436 meters. But notice that a good chunk of this interval is above 1 meter. So for the B interval and correspondingly for the C interval, because both of those have their upper limits are above 1 meter, it would be reasonable to expect that the population mean drop height to result in a 97% success rate could be 1 meter. We can't rule that out because it's in those intervals. So that's a good finding. Let's get going on number 5. So 5 wants us to create graphs that display the prediction error for each of the individual logistic regression models. Let's do that first. So in order to do that, we got to be able to figure out what those prediction errors are. So first thing we're going to do is go back here to, and this is the same output that we used from question 2, or we made in question 2 and then built on for question 4. So same output here. What we're going to do here is we're going to go up to the very top little red triangle. We're going to tell it, little red triangle, I want you to save columns. And there's a couple that we would consider here: prediction formula and predicted values. So we don't want formula because nothing's going to change in our data, so we just want the final value. So let's tell it predicted values. Okay, so we've done that. We're now going to go to our main screen, jump screen here, and there we go. So we now have a how's this going here? Something ain't right here. Okay, yeah, that's looking right. So when we did save the predicted values, it's giving you the predicted value for the success, and it's putting them in both of the, also with the fail. So like, for example, here we have A at 20.25 meters and the fail and the success, and they're both getting the same values. So we know that the model's prediction, given that it's the screen A model at a height of 0.25 meters, the model predicted 98.465% success. But the observed value, which is the, and we could use the rate field that they've already computed for us here. So the observed value is just going to be the number of not broken ones, or the number of successes over the total number of phones dropped at that level. So 25 successes out of 25 total drops. The actual observed rate is 100% 1, and this is the prediction here. So they also want us to make a new column on here that is going to be the difference between those, and that difference is what is our prediction error. So we'll call this one just difference because we know what that refers to. It's going to be numeric and it's continuous. Now, while we're on this launch box here, let's do column properties, formula, And we're just going to set this up, edit formula to do just like we did once before when we made another column like this. So the prediction error is going to be the rate, which, remember, that's the observed percentage of success minus the predicted outcome, which is right there. So okay, okay on that, okay there, and so now we got a difference. So in this first example with screen A at the 0.25 meter drop height, the observed is 100% 1. The predicted by the model is 98.465%. So the difference between those two is what our prediction error is here. Another common term for that would be the residual. So the difference between the predicted outcome and the actual outcome in this case is, and at this point, let's clean this up so we only see the success ones, and it'll only use the success ones. So what I'm going to do that is go to the jump data table here. Just click on any of the fail values. Right click in that cell. Tell it select matching cells. And we're now going to go over here to the row labels index on the left here. We're going to go into any of those blues, and we're going to tell it to hide and exclude. And it didn't work. Well, it's showing on the thing here, so it should work when we run this. So we got that set up. So now we're telling it don't use the fail data points for doing our visualization. So let's look at that first visualization. And for both of them, we're going to do Graph Builder, and it's going to come over here. And what you want to do is take the estimate, which it probably would be a good idea to rename that variable to estimate because it'll look better on your chart and stuff. So estimate is going to go to the X bottom axis, and then rate, which is the actual observed value, is going to go to that box, and we don't want to have the smooth line on here at this point, so we'll turn that off. And also notice that now it's got all 4 of the screen types in it. So let's do this. Let's go to our local data filter. That gives that over here, and we're going to tell it we want to filter by screen. So it's going to give us this set up here. So if we just click A, it's only going to look at A. So now we've got just our points from A on here, and now let's add in that reference line. So the line is really just X equals to Y line, and we're going to look at how they suggest we do that to do it. So they say a line was added manually via tools, lines. So let's see if we can figure out how to do that. I don't see tools on here anywhere. Oh, tools. Tools line. It's not doing, it's got a weird thing on it. I don't know. Well, how do we make it be X equals to Y though? I suppose we can just go from corner to corner, but that's the imprecise way to do it. Well, that looks pretty close. So, all right, that'll have to do. Maybe you can figure out how to make it better do that. But okay, so last thing we want to do for this one is to add the values as data labels. Right click on the height column, right click on the height column and select label. What's going on here, man? Okay, first question, where's the height column? Are they talking about in the original data set? So right click on the height column and select label unlabel. Is that one? Yeah, that's one. Highlight all the data points in the graph. Right click and choose rows row label. Right. Oh, now we lost that one. Right click and choose rows row label. Okay, I don't know what the heck they're talking about here. Let's see. Highlight. So we just somehow got to get those values turned on there. So let's go back to our graph builder here, and dang, we ought to be able to turn those on. So like points, we're gonna just let's tell it labels by value. Oh, what's that? Oh no, that's not right. Dang it. So I don't understand what they're talking about. Label by row, maybe. Oh, hey, look at that. I think, is that what we want? Yeah, cool, awesome. Cool, we got it. So label by row. Probably that went in conjunction with what we did for the height setting. But anyway, there's our first left-hand graph for screen A. So for this one, kind of looks like we're gonna need to manually do these. So with this one being done, I would tell it go to the graph builder, little red triangle, make sure it's not the local filter triangle. Save script to data table. I'm gonna call this one just to be able to remember this one, I'm just going to call it the left-hand one based on it being in the case on the left side. And we're going to call this one for screen type A. And telling it that, okay, it's now up there as a script. We also could have told it to be done and just have that. We could close out the local data filter and get our finished graph. So now you can see that this graph resembles this here, pretty close. And so that's cool. So that's that one. Now to do the other four left-hand graphs, invoke your local data filter or open it back up, and then just change A to B, and boom, there's the B chart. C, there's your C chart, there's the competitors chart, and you want to screen snip all of those. And speaking of screen snips, let me give you a tip that's gonna help you out with screen snips. So one thing that we can do is make the graph bigger so it has more definition and easier to read the values. Now, cool trick on Jump is to do the selector tool. So this thing up here is the selector button, so you can hit that. But the way I like to do it is on the keypad, just press the S key, and that's going to change it to selector tool. Let's make sure we're active there. So S, selector, and the keyboard's not working right. Usually it does, but we'll just go up here to the selector tool. We've now got the selector tool, and I'm going to click on the header for graph builder, and it's going to take everything underneath that and circle it. And this works great for any kinds of output. So when you want just a portion of the output, just click on that portion's header and it'll circle blue just that portion. Once you get it circled, hit Control C, just a plain copy. That puts it in. Oh man, something went bad here. Dang, hold on. Okay, and my most recent up-to-date tip is don't ever use what I just told you, because I don't know what it did, but it like totally crashed Jump, and I straight up lost all the work that I've done. I know I've saved that, and that wasn't even there, so I had to recreate the whole thing here. So don't do that, and just manually use your screen snipper for that. But anyway, hopefully I got this set up the same way. So we already looked at how to make the left-hand graph on there, and I figured out that so hide and exclude means that that value is not included in any statistical calculations that you do, whereas hide means that that value is not included in any visualization or graphs that you do. So we've got all our fails set to hide, which is what's important now. So now let's do that right-hand graph. So that's going to be graph builder. Drag that guy over here, and we're gonna put the height onto our bottom axis here, and we're then going to put the observed minus estimated, which is the difference, over here to damn, what's going on there? To that, and okay, so that's we're almost there on that one. Again, for this one, we got to do the local data filter, and we're gonna filter by screen, and let's just do the A. So there goes our A, and oh, now we have the challenge of the line again. So let's see here. Wow, something's weird. Yeah, it looks the same, but so our scale didn't match up to what the output has. So the way we could fix that would be to tell it, I think if we just right click in this axis, we'll tell it axis settings. We can tell it the minimum is going to be so the minimum should be negative 0.1, maximum should be positive 0.1. That's like how they got it here. So that looks cool. So let's take a look at what that's going to give us. So that looks good there. So that matches what they got pretty much. And now we got to figure out how to get that line going across the middle there. And to do that, I'm gonna, how do they do that? Tools, line. And I guess we just got to draw it here. So there's a much better way to do it. I'm wearing out, so I'm just going to do it this way. But and a lot of times in graphical software, if you press and hold either Shift or Control, it'll make it straight. But that's not working here. So I hate to do it like this. It's like a huge hack. Because that line should be straight across there. But anyway, that looks good. So I'll leave that to you to figure out how to make that on there. But that just represents a zero difference. So what this graph is telling us is, and we'll put no labels on there like they did with their graph. We can then tell it done, and there's the graph. If we wanted to make it more detailed, we just make it larger, or however we want to do that. So that looks okay at this point. We'll tell it save script to data table, and that's going to be the right hand. I forget what we called that. Right hand graph. Yes. Oh no, that's the right hand for A. Okay, so that's A. We got A done. Now next one would be just B. That one looks like that. Wow, that see how, remember B had the narrowest confidence interval, so that corresponds to having the lowest residuals around the difference. So the farther away each dot is from the zero line, that is how much difference the estimated value is from the actual observed value. So B is dialed in model, I must say. It looks like there's C, so C's pretty good, but B's still a lot better than that. Competitor, competitor looks pretty decent too. But anyway, so that's how to do that and get your graphs on that one. So that I think will finish us up with the jump work in here. So we got our number 5, which is create the graphs. Those are the 4 left-hand ones and the 4 right-hand ones like we just did. So so I would just show those all on the report or whatnot, and comment on how close to the estimated rates are to the observed rates, which we kind of just did. So again, looking at A is relatively not close to there's not a small difference between them. It has a relatively large distance between those. So that says that the model is not as good at predicting what it's trying to predict than, say, Model B, because the Model B residuals are way smaller than that. And the closer to each line, like here, this is saying that at a 0.5 meter drop height, then this is our data point for that difference, and that's telling us that the difference is positive 0.0631. So the observed value then is 0.006 higher than the predicted value based on this graph. So that's what that's telling you, and good luck in putting that all together and doing the rest of your case. So let's see. And I'll question 3. So just look back at, if you did the part 2, you can look at those and look at these. The estimates that we made in this current case, the case 3, are going to be more precise, based on, I would say, largely because the sample size is higher. So you can compare sample size between the 2 cases, and that should provide some insight into that. So I think that's everything for this one. We got all the work done, even though I lost it all, so I'm not going to be able to do any follow-up on that, probably. But anyway, that's it. Good luck with that one. Thanks for watching. This is Kevin B. Tutor. See you later.